Hello class, I'm going to be going over some of the problems from assignment 3-4. Hopefully it'll help you to do the rest of the problems and to get a good understanding of the concepts that we need to use. So in this first problem we're given that angle 1 is congruent to angle 2. And what we're trying to prove is that ray OR bisects angle NOP. Now the first thing I want you to notice is that NOP is just the sum of angle 3 and angle 4. Those two angles make up angle NOP. Now if ray OR bisects NOP, then that also means that what we just have to show is that angle 3 is congruent to angle 4. Alright, if a ray bisects a large angle into two congruent smaller angles, or if it cuts a large angle into two congruent smaller angles, then it bisects that angle. So that's what we really need to show, is that angle 3 is congruent to angle 4. Now we can tell that angle 1 is supplementary to angle 3, and that angle 2 supplements angle 4. All right, and now what's the reason for that? Well, if two angles added together form a straight line, then we know that they are supplementary. Right, so we're pretty much done with this proof at this point. I want to use a little bit of color coordination to help us to see the next step in the proof process. All right, so we can already show that angle 3 is congruent to angle 4, and it's just basic arithmetic is going to show this to us. So if angle 1 is congruent to angle 2, as we showed in step 1, then if angle 1, it's got to have some measure. It could be 100 degrees, it could be 150 degrees. Whatever angle 1 is, angle 2 has to have the same measure, the same number of degrees as angle 1. So if angle 1 is, say, 100 degrees, then angle 2 must also be 100 degrees. Now if angle 1 is 100 degrees, then angle 3, because it supplements angle 1, right, it has to be 80 degrees. Angle 1 plus angle 3 have to add up to 180 degrees because they form a straight line. So, I'll say it again, if angle 1 is 100 degrees, then angle 2 must also be 100 degrees, but angle 3 must be 80. Now if angle 2 must be 100 degrees, then angle 4 likewise must be 80. Or in other words, angle 3 and angle 4 must have the same number of degrees. They must, in essence, be congruent with each other, as I show in step 3. So, and the basic simple way of giving the reason for why angle 3 is congruent with angle 4 is, if two angles are congruent, then their supplements are also congruent. Now, I don't want you to memorize that reason. I want you to kind of think about it. Go back a little bit to where I was kind of talking about why angle 3 must have the same number of degrees as angle 4, so that this reason doesn't seem like something you just memorized, but rather something intuitive. Now, angle NOP equals or just is angle 3 and angle 4, and we can see that in the diagram, so that's our reason. That's just shown in the diagram. And so we can already just go to our final step. All right, ray OR bisects angle NOP, and that's because when a ray bisects a large angle, then it's cutting that large angle into two smaller congruent angles, and those two smaller congruent angles are 3 and 4, and we showed in step 3 that 3 and 4 are in fact congruent to each other, so that's our reason. All right, and so that's the end of that proof. It is a really simple one. Right. Now, if now we're trying to show that FD is a median. We're given that FD is an altitude. So let's go over the differences between a median and an altitude. So when thinking about medians and altitudes, it's often helpful to think of a triangle as laying on one of its sides being completely horizontal. So I have the shortest side of this triangle being completely horizontal. That's the side that this triangle is laying on. All right, so for this side, if we look at the median of the angle that's up in the air, the one that is not being laid on right here, the median from that angle is going to connect it to the midpoint of the side that is opposite that angle. All right, so this green arrow is the median. It's connecting this angle at the top to the midpoint of the side opposite to it. The side opposite to it is only the shortest side, segment AC. And the midpoint of that shortest side is going to be B, meaning that segment AB is congruent to segment BC. And the median is just going to connect that one angle to the midpoint B of the side opposite to that angle. Now the altitude is extending from that same angle. It's going to extend from that angle in such a way that it is perpendicular to the side that is opposite that angle. So in other words, the altitude from this angle that's on the top, right, the altitude from that angle must be perpendicular to segment AC. So I've shown that with this little box here between the segment AC and this vertical line. Right, and so that's the altitude. It's always going to be perpendicular to the side opposite from the angle that it's extending from. Now, each one of these angles has a median and an altitude to go with it. So let's just look at one of the other angles. Okay, so I've put the triangle laying down on its longest side now. And so now we have another angle that's up in the air. The median for that angle is still going to go from that angle to the midpoint of the side opposite to it. So now that side opposite to it is the longest side of the triangle, segment AC in this case. The median must go to the midpoint of that segment, which is going to be B. And so again, that means that segment AB is congruent to segment BC. Now the altitude, it's going to go straight down. It's going to be perpendicular with that side opposite to it again. Whenever you have a triangle laying flat on one of its sides and you're looking for the altitude for the that one angle that's up in the air, in that scenario, the altitude is always just going to go straight down the way I have it. It's going straight up and down. Okay, but I don't want that to confuse you. The main point is that the altitude is always perpendicular to the side opposite to the angle that the altitude is extending from. So we can even change the orientation of this triangle, but that's not going to change the altitude or the median connected with that particular angle. All right, we got to look at the example of an obtuse triangle because it does present some difficulties. All right, the median is still straightforward. All right, it's going to go to the midpoint of the side opposite of the angle from which that median is extending from. All right, but what are we going to do with the altitude? The closest the altitude can get to being a right angle is if it goes right along this one side of the triangle. All right, that's the closest it can get to being a right angle while staying within the bounds of the triangle. But it's clearly not a right angle. So this altitude is going to have to go outside of the triangle. So what we do is we're just going to extend this opposite side. All right, so I just gave this opposite side an extension, and now the altitude has to be perpendicular to that extension, as I have it there. Right. Now the altitude has to be perpendicular to the extension of the opposite side. So I'm going to show you something that is not the extension of the opposite side. All right, this new dashed line, that's not an extension of the opposite side, so you can't just make the altitude perpendicular to that dashed line. It has to be perpendicular to that dashed line that I showed on the prior slide. All right, so again, this is our median, and this is our altitude, and what I have right up here is wrong. So not like that, but on the but like on the prior slides. Okay. Now angle CFD is congruent to angle EFD in this problem. That's given to us, and FD is an altitude. That's also given. If FD is an altitude, then what else do we know? What other angles do we know must be congruent? I want you to think about that before I go to the next slide. So here I've just shown that CFD is congruent to angle EFD as is given. But here's what I wanted you to figure out is that if FD is an altitude, then angle CDF must be a right angle, and so must angle EDF. Reason if a segment is an altitude, then it forms right angles with the opposite side. So that's pretty simple. Now if angle CDF and angle EDF are both right angles, then we know that they must also be congruent to each other. If two angles are right angles, then they are congruent. Right. So this is what we're pretty much given. Now how are we going to prove that FD is not just an altitude, but also median? What two things must we prove are congruent? Well, we're going to have to prove that D is a midpoint and that CD is congruent to DE. Right, because remember, median goes from an angle to the midpoint of the opposite side. So D is a midpoint, and that means that CD must be congruent to DE. How are we going to prove that? Try and take a moment to think about that. Well, we can go and show that FD is congruent to FD according to the reflexive property. And once we've done that, we can show that triangle CDF is congruent to which other triangle. Make sure that you get the arrangement of the letters right, because there's only one correct arrangement of the letters. So what is that arrangement going to be? It's going to be that triangle CDF is congruent to triangle EDF. Now once we've shown that those two triangles are congruent, then we know that sorry, I forgot to mention that. We know that these two triangles are congruent because of the angle side angle postulate. Right, because of the angle side angle postulate. And now we know that CD must be congruent to DE. CD must be congruent to DE because of the CP-CTC. Congruent or corresponding parts of congruent triangles are congruent. Right, and CD and DE are corresponding parts of congruent triangles, so they must be congruent. Right, so if those two segments are congruent, then we know that D is the midpoint of CE. All right, if a point divides a large segment into two smaller congruent segments, then the point is a midpoint. So now we've shown that FD extends from an angle F, to the midpoint of the side opposite that angle. So we have proved that FD is a median. All right, this is the last problem we're going to look at. We're told that angle AEB is congruent to angle DEC, so let's go ahead and mark that. All right, AEB is congruent to angle DEC. We're also told that segment AE is congruent to segment DE, so let's go ahead and mark that. And then we're told that angle A is congruent to angle D. Right. So we have enough information here to see that these two skinny triangles, one on the left and one on the right, are going to be congruent to each other. So triangle AEB is going to be congruent to which triangle? Make sure that you get the letters in the absolute correct order. There's only one correct order here. Right. AEB is going to be congruent to triangle DEC. And what's going to be the postulate? Right. It's going to be angle side angle postulate. Now, once we know that, there are certain other things that we know. We can't go straight to talking about AC and BD, but we do know that parts of these two segments must be congruent to each other. Namely, we know that AB must be congruent to CD. Try and think of the reason here. It's going to be because of CP, CTC. All right, those are corresponding parts of congruent triangles, so they must be congruent. So now, we're going to see that AC is congruent to BD because of the addition property. I kind of want to give a good demonstration of that though. So segment AB, it's gotta have some length. It could be 5 inches, it could be 10 inches. We don't know how many inches it is, but it's got to be something. So we're just going to give it a length. We're just going to say we're just going to say AB is 5 inches. It doesn't matter ultimately how many inches it is. This reasoning is still going to work. If AB is 5 inches, then CD must also be 5 inches because AB is congruent to CD, so they have to have the same lengths. So CD must also then be 5 inches. Now, this segment BC, that also needs some length. We don't know what it is, but it doesn't matter. It could be 10 inches, it could be 15, it could be 20. Let's just say that BC is 20 inches. So if BC is 20 inches and AB is 5, then what is length AC going to be? Right? AC is that's equal to AB plus BC. That's what segment AC is. It is AB plus BC. And AB is 5 inches and BC is 20 inches. So AC is 25 inches. The same exact thing is going to apply for BD. BD is also going to be 25 inches. So in other words, we know that AC must be congruent to BD. All right, and we're saying this because of the addition postulate. All right, AC is congruent to BD because of the addition property, I should say, which just simply states that if you add the same segment, in this case BC, to two congruent segments, AB on the one hand, CD on the other, then those two different sums, AB plus BC on the one hand and CD plus BC on the other, those two sums have to be equal to each other, and so those two sums must be congruent to each other. So we've just proved that AC is congruent to BD, and that is the end of this show.